Hello everyone, this is my next video. Today I am going to explain Leetcode question number 1137, nth Tribonacci number. It is similarly as Tribonacci series, okay? The Tribonacci sequence Tn is defined as follows. T0 is equals to 0, T1 equals to 1 and T2 is equals to 1 and Tn plus 3 is equals to Tn plus Tn plus 1 plus Tn plus 2 for all n is greater than or equals to 0. We given n, we need to return the value of Tn. Okay, what they given one, they will be given on n value. We need to find the T of n, Tribonacci of fourth. Okay, they given an explanation. Let's discuss in the whiteboard how it is going to work. See what they given n equals to 4. Okay, and the output is 4. See, first we can understand the base conditions. The base condition, if n, there will be 2. Okay, if n equals to 0 means just I will return 0. If n is equals to 1 or n is equals to 2, I will return 1. Okay, see, 4, I will recursively call the previous conditions. If n is 0 or 1 or 2 means this will I will take. If n is neither 0 nor 1 nor 2 means what I will use, I will call the previous values. How means trib of n minus 1, trib of n minus 2 and trib of n minus 3. Here the n value is 4. Okay, see, trib of 4 minus 1 means 3. Trib of 4 minus 2 means 2. Trib of 4 minus 3 means 1. Okay, here 3 I will again recursively calling. Trib of 3 minus 1 means 2. Trib of 3 minus 2 means 1. Trib of 3 minus 3 means 0. See, these 2 and trib of 1 will directly call return 1. I will directly returning 1. Just I will add them. 1. I will add them. Trib of 1 is 1. Trib of 0 is 0. I will add them. 1 plus 1 plus 2 plus 0 plus 1 plus equals to 4. Okay. See, my output is 4. Okay. This is by using a brute force approach I showed. Now we can enter into the coding part. Okay. I will check the n is 0. If it is 0 means I will return 0. Okay. Next I will check if the n is 1 or n is 2, I will return 1. Okay. After that, if n is neither 0 nor 1 nor 2, then I will return the sum of all the calling functions for t of n minus 1 plus t of n minus 2 plus tn of n minus 3. I will be recursively calling them. Okay. Just I showed already. Once again I will show. See here n value what is there? 4. Okay, I will call them. 4 trib of 4 minus 1 is 3 plus trib of 4 minus 2 is 2 plus trib of 4 minus 3 is 1. Okay, this will be directly calling 1 plus 1. I will call them 2 trib of 3 minus is 1 trib of 0 1 plus 1 plus 0 plus 1 plus 1. Total I will getting 4. Okay, this is, now we can understand the time complexity and the space complexity of this code. Time complexity is big of 3n and space complexity is big of 3n. Where here n is the input integer, because the function we are calling recursively, we are calling it 3 times. Okay, these. Okay, so our time complexity will be big of 3n. When come to space complexity, we are calling the 3 functions recursively and we are storing in the stack. Okay, in the stack we are storing the each memory, so it is taking the space complexity of 3n. There is a better optimal solution with time complexity and space complexity by using the dynamic programming. I will show that now. Yeah, in this logic, what I done, starting I taken the base conditions. If n equals to 0, I will return 0. If I will check if n is 1 or 2, I will return 1. These two base conditions. Okay. After that, I created an array dp of size n plus 1 to store the intermediate results. Okay. Initially, I taken the values of dp of 0, dp of 1, dp of 2. I set a dp of 0 to 0 and dp of 1 to 1 and dp of 2 to 1. Okay, after that I started to iterate the for loop. It starts from I equals to 3 and I is less than or equals to n I plus plus, means it starts from third in element up to it will go to the last element. Okay, in that what I will calculate, I will calculate the dp of I minus 1 plus dp of I minus 2 plus dp of I minus 3. Okay, how it is going to work, I will show. Here the value I taken n equals to 4. Okay, I will start from 3. Okay, for loop it will start from 3. Okay, what I will do, I will do dp of 3 equals to, see, dp of 3 minus 1 means 2. Okay, dp of 3 minus 2 means 1 plus dp of 3 minus 3 means 0. Okay, see, dp of 2 already I taken value as 1, dp of 1 also 1, and dp of 0 also 0. I will calculate them. I will get dp of 3 equals to 2. Okay, now we can calculate when I will be equals to 4. Okay, dp of 4. See, now I will use this condition. 4 minus 1 means dp of 3 plus dp of 4 minus 2 means 2 plus dp of 4 minus 3 means 1. Okay, dp of 3 what I got? 2. 2. dp of 2 means 1. dp of 1 means also 1. I will add them. 2 plus 1 3, 3 plus 1 4. dp of 4 is equals to 4. So you can observe that now our I value will become 5. This condition will become false because our n value is 4. 5 is less than or equals to 4. This condition will become false. We will come out of the for loop. We will return the dp. The time complexity and space complexity both are big of n. Okay, where n is the input integer, we are using the for loop to find the nth Fibonacci number. Okay, so it's taking time big of n. Where come to the space complexity is taking big of n, where n is the input integer. We are taking the dp to store the intermediate values, so it is taking the space of big of n. There is another solution with efficient space complexity that I will show now. Yeah, in this logic, what I done, I taken first two base condition. Previous logics, what I showed no, same base conditions. I will check if n is 0, just I will return 0. If n equals to 1 or n equals to 2, just I will return 1. Okay. After that, I take if the n value is neither 0 nor 1 nor 2, then I will take these values T0, T1 and T2 and result. I will be set it to T0 to 0, T1 and T2 to 1 and result to 0. Okay. After I started to iterate the for loop, it will starts from third element up to it will go to the n element. In the for loop, I will calculate the result. Result I will add the T0, T1 and T2. I will add and will be stored in the result. After I will update the values, T1 value will be stored in T0, T2 value will be stored in T1 and result will be stored in T2. After the completion of all the iteration, finally what the result is there, no, that I will return. Okay, this is the logic. How it is going to work, I will dry run now. I will go with this example. When n is equals to 4, right, our t0 will be 0, t1 will be 1, t2 will be 1, and my result will be stored 0. See, my result, see, 0 plus 1 plus 1, my result will be 2. Now my T0 will be what the T1 will be there, that will be updated. My T1 will be now T2 whatever 1. Yeah. Now my T2 will be stored result. Result what came 2. Okay. When when I is equals to 3. Now when our I value will be 4, then all values will be updated values will be stored. Now then our result will be now, see, T0 what is there 1 plus T1 what is there 1 plus T2 what is there 2. My result is 4 now. Okay, now our updated value will become T0 will become 1, T1 will become 2, T2 will become 4. Okay, see, after that my I value will become 5. Now condition will become false because I value is 5, where n is because n is 4. Okay, because starting I told we are taking n equals to 4. See, okay. This condition become false, we will come out of this for loop, and finally we return the result. Result, what is there? 4. My result is, see, you can observe that my output has become 4. This is the logic. In this logic, we can discuss now the time complexity and the space complexity. The time complexity is taking big of n. When it comes to the space complexity is taking big of 1. Here, n is the input integer because we are using the loop to iterate all the n times to find the Fibonacci number. So it takes time of big of n. When come to the space complexity is taking big of 1 because we are not using any extra amount. We are using only the constant amount of. So our space complexity is big of 1. Let's run the code. Yeah, this is accepted. We can submit the code now. Yeah, this is accepted solution. Thank you guys for watching my video.